I want to show you how to prove the first derivative test and explain it a little bit. So here's the idea. You're given a function and you want to figure out a way when you've got a critical point to determine whether that critical point is a local max or a local min or something else entirely. So here's the setup. You've got your function y equals f of x. And you've already identified a critical point. So you know that C is a critical point. So you know that f prime at the point C is equal to 0. And you need to know more than that. Technically speaking, you need to know that the derivative is also a continuous function. But if you assume that, then you're good to go. And that's almost always going to be the case in this calculus class. And so you're wanting to determine, could this be a local max, a local min, or something else? And the first derivative test says, well, suppose you know that the sign of the derivative at the point C is switching from, say, negative to positive. And I'll explain what I mean graphically. So if you look at a graph of f prime of x, and you know it's 0 at the point C, that's what's given to you, but say you know that if you zoom in on the point C, the graph of the derivative function kind of looks like that, like it cleanly crosses the x-axis at the point C, so that it's switching from negative to positive. So maybe there's some small interval from A to B where the derivative is switching from negative to positive. So that means the derivative is strictly negative on the interval from A to C and strictly positive on the interval from C to B, this being your graph of f prime. So what does the graph of f look like? Let's go down a level. Look at the graph of f. And well, if your derivative is negative on an interval, then we've just found out in a previous video that if you're negative, you have to be decreasing down. And then if you switch to positive, you have to be increasing. And here's your point C, and maybe you found this is the same interval from A to B, right? It's just that's the derivative. And that's now what the function looks like schematically. So starting with knowing that the derivative at C was equal to 0, and then knowing that the derivative cleanly crossed from negative to positive at the point C. The mean value theorem then tells us we have to be switching from decreasing to increasing, which means that f has to be a local minimum. So we conclude that if the derivative switches from negative to, I don't know why I put a less than sign there, if it switches from, let's say, negative to positive at C, then you must be a local min. Then f of C has to be a local minimum. And there's a corresponding statement if the derivative had the reverse behavior, because say that you're over here at point C and f prime looked like that. Then when you go and look at the graph of f schematically, it's going to be switching from increasing, because that's where the derivative is positive, so increasing, then to decreasing. So that gives you a local maximum, the same argument. So if f prime switches from positive to negative at C, f of C is a local maximum. That's called the first derivative test. You locate the critical points. You want to know if it's a max or a min or something else. And so you can determine that by looking at whether that derivative is switching sign. So I keep saying max or a min or something else. What do I mean by that? So there's other things that could happen other than just switching from negative to positive or positive to negative. Here's an example. Here's an example of a third thing that could happen. It's a classic function you've seen before. If I just look at y equals x cubed, say, and I take c equals to 0. So look at the graph of that. Sort of what it looks like. And if f of x equals x cubed, then you know that f prime of x is 3x squared. So in particular, f prime of 0 is equal to 0. So 0 is a critical point, but is it a local max or a local min? No, it's neither one. And in fact, if you look at the derivative, and if you graph the derivative, here's what it looks like. It looks like a parabola. So it did not exhibit the behavior of switching from positive to negative or negative to positive. The derivative here stayed non-negative the whole time. And even other things can happen too, but what this test says is if you are in a situation where you're switching from positive to negative or vice versa, then it must be true that you're either at a local min or local max, respectively.